Hello everyone, this is Cameron Snow with Danomics.com. So, in this video I want to review our new TOPS interpolation tool that's part of our geoscience package. So one of the scenarios that you may run into is that if you have a large number of wells, you're most likely not going to have a complete TOPS framework picked in this case. So if I look at what I have available here, so here in my map, I'm just going to very quickly choose to use a structure map here. And you know, when I look at this, I've picked a lot of these wells. I've picked a lot of tops here, but um, I've not gone through and picked out a full stratigraphic framework for all of my tops. And if you have a lot of wells, you may not want to spend the time doing this because it can take weeks to do if you have thousands of wells and you have a lot of stratigraphic intervals that you want to define. So the question is, how can we accelerate this process, right? That's what we're about doing in Danomics, is we're about speeding up this type of process. So we're going to look at a new flow that we have developed to help with that particular scenario. So what we're going to do is we're going to create a new flow called the TOPS interpolation flow. Remember, if you're not familiar with flows, the way we do this is you just say File, and you say New Flow, and that'll bring up an empty flow. And then we're going to add blocks to this flow. So in this case, we're going to start off, we're going to have a log input block. And here I've chosen the database that I want to use, and I'm looking at all wells. I've chosen a points input block, and so points and tops have the same file structure, and so that's why we're using points input here. But notice I've selected a .tops file, so I've selected the tops that I've picked, and I've picked these for about 1,000 wells here, but I have about 5,000 well logs. And then in TOPS Interpolate, I tell it the log data set that I want to use and the well headers that I would like to use, and then I have my TOPS output, which I've called TOPS Interpolation. And I'm going to hit the run button on that. And when I do that, it will initialize, it'll start a new mapping job, and then it'll write a TOPS file out for me. So I want to go over what this is doing behind the scenes, just so you understand that. So our log interpretation, it's pulling in the logs, but we need this mainly just so we have some of the log header information, such as the log start depth and the log stop depth. And the reason why is because we are going to look at where we have a grid that should intersect the logs. When we're doing this points input, we're pulling in our TOPS file, and in the TOPS interpolation, what's going on behind the scenes here is we create a grid of each formation horizon. So we're creating structure maps at each level, and we are then looking at the intersection of that structure map and the wellbore. And if a top has not been picked in that particular well, we will interpolate that top. That means we will extract that value at the intersection of the structure map and the well log, and then we will write that out here in our TOPS output file. So that is how it works, and what we're doing is we are essentially creating a structure map at each stratigraphic interval, and so that way you will have a complete TOPS framework picked out, and you won't have tops that shouldn't be deeper than the wellbore or shallower than the wellbore. So it does have some logic built in there, but it's not the most sophisticated process in the world. It is simply an extrapolation, or an extraction, I should say, from a map. So a few things to think about before you do your TOPS interpolation that I'd like to point out. The first thing here is, it's useful to think about where you have picked the tops out. So here, I've picked tops on a few hundred wells, and within these wells, what I've tried to do is get good coverage across this area, so we have a good understanding of the general structure. And so if I come in here in between a couple of wells, it should be very close um, to the tops that I have picked, right? So it all depends that when you come in here and uh, look at your structure maps, are they representative of what you would be expecting? So, in this case, if we wanted to make a map of the Parkman, we do that structure map, we look at it, and we say, all right, does this accurately represent the structure? And if so, then we can, when we're add new wells, we can extract those out. Like I said, this project we're running on has about 5,000 wells in it in the database. And, here in about the 5 minutes of the video that we've been doing, we're about 85% of the way through. And so, this extraction is a fairly quick process. In terms of how to QC this, the best way to do it is to generate cross sections after the fact and see how accurate your interpolation is. You may need to go in and pick a few more seed tops to help get those grids shaped up. And the last thing here is to remember where it's important to have very high levels of precision in your interpretation workflow, and where you can deal with having tops that maybe aren't as accurate. So looking here at this example, if I really zoom in here and think about where is it important to have high levels of accuracy, well, here the Niobrara, this is a very different formation from the formations above it. We have organic shell here, high organics, high gamma ray values, whereas above it, I have a stack of alternating sands and shells in here, very homogeneous lithology. So if I'm a little bit off on my Parkman top or my Sussex top or my Shannon top, that is not a big deal. But here, the Niobrara, because it's delineating an organic shell, and because the parameters picked in this shell are quite different from those of adjacent zones, this is an area where I would need to do a higher level of QC. Whereas for something like the Parkman or the Sussex, I know for getting out my well logs, I can deal with a little bit more uncertainty in those because the parameters are very similar between zones. So it's when you have big breaks or big changes in the way your parameters have been set, that is where you want to pay attention. And here we see that our tops interpolation flow is just finishing up. And once that finishes, it will be written here to our file folder tree. And we can take a look at that here. Okay, so it's just finishing up. There we go. It is now finished, and we have this tops interpolation.tops. We can click on that, and we can now see that we now have a complete stratigraphy for each of the wells. And I would also like to point out that in the case of each of these, it is only extracting the tops that would intersect the well. So for example, if a well wasn't drilled deep enough to intersect the Niobrara, there won't be a Niobrara pick or any of the deeper picks in that well. But now we should have a very complete stratigraphy. The other thing to remember is that once you have generated this, you need to tell your CPI file to use that set of tops. So remember, you would just come here and you would choose those interpolated tops. So we can use those in here. And for the wells that you have already picked, there shouldn't be any changes. There could be if you have a lot of very tightly spaced wells. You may notice some small changes, but in general, the top should be an exact match. Okay, so just to review that one more time, we create a new flow, we put our logs into the flow, we put our tops into the flow, then we use the log data set and the well headers. This will, remember, it'll generate a series of structure maps behind the scenes, and then we'll look at where those wells intersect those structure maps. And finally, we will generate a output set of tops that will cover all our formations of interest. And that will be written out here as a tops file in our folder tree. Okay, this is a new feature. I know there's a lot going on behind the scenes in this. So if you have any questions, feel free to email me at support@danomics.com, and we can get you working on this tops interpolation tool so you can have a better understanding of how it works.